Good afternoon and welcome to all participants in the today's session. So today we are having two sessions. One is with the design for the factory automation and one is on Industry 4.0. So the session will be started. So I want to share the ACMA Center of Excellence movie for the introduction. So I want to share the ACMA Center of Excellence movie for the introduction.
Excellence is a learned behavior. It's an art and a science that can be taught.
And the ACMA Center for Excellence, Saksham, imparts
So I want to share the ACMA Center of Excellence movie for the introduction.
Auto component manufacturers to provide best-in-class quality to our customers.
Excellence is a learned behavior. It's an art and a science that can be taught.
And the ACMA Center for Excellence, Saksham, imparts.
So I want to share the
Future.
to augment the capabilities of the Indian auto component sector in line with the changing customer needs and global technological developments. The ACMA Center of Excellence, Saksham, has been conceived to upscale and create talent for the industry. The Center of Excellence focuses on four-pronged mission, providing a conducive learning environment for enriched experiential learning, supporting the auto component industry for quality first and safety must, facilitating an organizational culture that places organizational goals above individual ones, enabling design in India for new product design and development.
In order to provide a soft skill and a technical skill to the industry, we have created the Center for Excellence along with the partnership of our industry academia such as IIT, AOTS and Maruti Center for Excellence.
Setting up of a Center of Excellence has been on ACMA's agenda for last several years, and I'm glad that this year's our dream took a concrete shape. We have now an ACMA Center of Excellence, Saksham, set up in Sonipat. Saksham, as you all know, means empowered, enabled.
The Center for Excellence will lean on subject matter experts, industry experts, and look at bridging the gap that exists between existing capabilities in our industry and what the automotive industry will require as we make leaps in terms of technology.
Implementing new technologies, new processes, aiming for zero defect quality, and digitizing the entire supply chain. All these changes require highly skilled manpower, having the right aptitude and the right attitude. The Center of Excellence is established precisely to be able to impart these skills.
The Center of Excellence would help the members in augmenting the skill in the areas of automation, smart manufacturing, lean manufacturing, and bringing
starting se play karo.
It's also very important that we have a campus. The campus creates an academic environment which is more conducive to learn.
हाँ starting से play करो. हाँ ठीक है play करो.
Excellence is a learned behavior. It's an art and a science that can be taught.
And the ACMA Center for Excellence, Saksham, imparts world-class technical and behavioral skills,
enabling auto component manufacturers to provide best-in-class quality to our customers,
along with creating a safe and productive work environment.
Saksham is all about building capabilities for the future.
To augment the capabilities of the Indian auto component sector in line with the changing customer needs and global technological developments, the ACMA Center of Excellence, Saksham, has been conceived to upscale and create talent for the industry. The Center of Excellence focuses on four-pronged mission, providing a conducive learning environment for enriched experiential learning, supporting the auto component industry for quality first and safety must, facilitating an organizational culture that places organizational goals above individual ones, enabling design in India for new product design and development.
In order to provide a soft skill and a technical skill to the industry, we have created this Center for Excellence along with the partnership of our industry academia such as IIT, AOTS and Maruti Center for Excellence.
Setting up of a Center of Excellence has been on ACMA's agenda for last several years, and I'm glad that this year's our dream took a concrete shape. We have now an ACMA Center of Excellence, Saksham, set up in Sonipat. Saksham, as you all know, means empowered, enabled.
The Center for Excellence will lean on subject matter experts, industry experts, and look at bridging the gap that exists between existing capabilities in our industry and what the automotive industry will require as we make leaps in terms of technology.
Implementing new technologies, new processes, aiming for zero defect quality, and digitizing the entire supply chain. All these changes require highly skilled manpower having the right aptitude and the right attitude. The Center of Excellence is established precisely to be able to impart these skills.
The Center of Excellence would help the members in augmenting the skill in the areas of automation, smart manufacturing, lean manufacturing, and bring in manufacturing excellence.
It's also very important that we have a campus. The campus creates an academic environment which is more conducive to learning.
The automotive industry in India and globally are undergoing rapid technological changes on the front of emissions, safety, and environment. It is imperative for the Indian auto component industry to ensure that our shop floors, as well as our products, are world-class, as also on the cutting edge of technology. Our long-term vision is to offer use of the shared resources at the center by the industry for co-development of products and creating intellectual property.
We request the ACMA membership to encourage their associates, to encourage their management to come forward and train at the ACMA Center of Excellence and be future ready.
Good afternoon. रागिनी दीपक कहाँ है?
Yes, sir.
हाँ चलो अभी क्या प्रोग्राम है चलो.
Sir, actually, I was just playing that presentation of ACMA Center of Excellence services so that participants come to know about all the services what ACMA Center of Excellence is providing.
Go ahead.
Thank you. So it was a short introduction about the what all ACMA Center of Excellence is providing in terms of industrial services and trainings. So now I do warm welcome for the participants, all the participants for today's event, Mr. Gaurav Sarup from Marshall Machines Limited, and Mr. Deepak Wal from Dassault Systems.
Good afternoon, everyone.
Good afternoon, sir.
Thank you, Deepak.
Yeah, good afternoon all.
Good afternoon.
Okay. So, DP sir, so can we formally start like today's program with Mr. Gaurav Sarup, or is there anything else?
Yeah, I just want to take a half a minute. So I think Marshall Machines and Dassault Systems, so we would like to thank you for your support. And I just want to take a half a minute that these programs, why we are designing for the benefit of the industry. See, the change is not the need now. It is a mandatory now. So it is not an option that we should look for digital solutions or working on design compliance and design competency in our manufacturing sector. So I think Marshall Machines, we are fully aware of what are their services. And the Dassault system also, we have a 16 high-end workstations laboratory in our Sonipat campus also, which people can use virtually also. So we'll be coming with a proposal that you can sit in your home and pay little charges nominal, and you can use our services. So I think both the programs are very relevant and suitable to the industry right now. So I want all the people to take maximum benefits, and suppose the time is short, we cannot take all the questions. I think you can do write to us, and we'll be happy to connect with both the faculties today. So I welcome Marshall Machines and the Dassault team, and I hand over this to Mr. Gauravji. Gauravji, welcome.
Hello, Dineshji, thank you very much. I am very honored and happy to be here and on this forum. And it gives me great pleasure to discuss a subject of this importance, which is Industry 4.0 and the technologies which I call the low-hanging fruit of Industry 4.0. And along with that, there's another very vital technology which we call affordable automation. So when we combine these together, affordable automation along with Industry 4.0 technologies, and those technologies which are relevant to the manufacturing sector, because industry is a very wide term. And here we are focused mainly on manufacturing, and that too specifically manufacturing of automotive components. So when we combine these relevant technologies together, we come to a term which I like to use, which is manufacturing 4.0. So today I will be speaking about the three core technologies and automation which go into making manufacturing 4.0. So Dineshji, can I start or do we need to wait for somebody?
You can start now officially, no problem.
Okay, fine.
So 1 minute, we have also made this live on the YouTube, and link is already shared, and
right.
People are watching on YouTube also. So go ahead.
Okay, fine. So once again, namaskar, and thank you for having me on this platform, wonderful platform of ACMA Saksham. And my subject today is manufacturing 4.0, which is basically a subset of Industry 4.0 and automation. So I'll just share my screen with you. So Dineshji, is my audio clear and is my screen visible and is it moving?
Yeah, your audio clear. You are also clear. You are looking very fresh, and audio, everything is good.
And able to move the slides?
Yes, it is very fine. No problem. Go ahead.
Okay. I like to check all these things. It doesn't look nice. I'm 5 minutes into the presentation and pata chala ke wo to audio nahi aa raha.
You are doing exactly Industry 5.0 work now. No problem.
Chalo. Okay. So on this light note, let us start talking about a subject which is very, very important for the survival and the growth of the Indian industry, manufacturing sector. So first of all, the question before us is, why does manufacturing need transformation today? And there are three reasons. The first reason is that profits are under pressure. I think somebody has to mute their microphone. Please mute the microphone because some audio is coming. So the first reason why we need transformation is that profits are under because of demanding customers and aggressive competitors. Second, there is an acute shortage of personnel or workmen, especially machine operators. This shortage was there even before the COVID pandemic came, but this shortage has become more aggravated thanks to the pandemic. No thanks to the pandemic. Third, in general, most manufacturing units are reporting poor OEE of their plants. OEE stands for overall equipment efficiency, which is a measure of how well your plant and machinery are functioning. So because of these problems, we need a solution. And I have given a catchy name to this solution so that it is more easily remembered and people will want to adopt this technology. I have called this IAM, which stands for I am Manufacturing 4.0. So these are actually three terms, I, A, and M, and happily they combine together to form a sentence, I am Manufacturing 4.0. So, as I mentioned earlier, and what I have shared on the screen, that manufacturing with optimized processes, with vastly reduced dependence on manpower, and having a system which generates profits, is competitive, and can bear shocks like the COVID shock or tomorrow some other shock. Those are the essential components of manufacturing 4.0. And this manufacturing 4.0 has three essential components, I, A, and M, which I will explain now. I stands for improvement. And this improvement is basically of two types. The first improvement is productivity improvement, and the second improvement is quality improvement. So I stands for improvement. How do you improve the productivity? If we talk about machining, because a lot of auto component manufacturers are doing machining primarily. So if we talk about machining, the improvement in productivity is because of better parameters, better machining parameters, which are enabled by technologies such as rigid machines with vibration damping systems, as well as by using technologies like high pressure coolant. So in my presentation today, I'm not going to go in depth in all these. I am just giving you an introduction that these are the areas you need to focus on. So for manufacturing 4.0, the first thing you need to focus on is improvement, and that is productivity improvement through parameter improvement, through use of technologies like high pressure coolant. The second thing you need to focus on is quality improvement. And for quality improvement, we have a technology called IoTQ, or Internet of Things for Quality. So it's a use of number of smart technologies put together in the form of gauging stations and detection systems and smart quarantine systems. So all these put together help you to approach zero defect production. Now, the first part of this IoTQ, or this method to approach zero defect quality, is a gauging station by the name Smart Correct. So this gauging station performs three functions. It eliminates the need for three kind of skills of the operator. The first skill, we say measurement skill, that operator needs to be able to measure properly the job that is being produced on his machine. Second thing is he needs to be able to use his judgment to see where my process is and what I need to do to stabilize the process, to ensure that my tolerances are maintained. They don't go out of the drawing tolerance. And third thing is inputting that. Whatever correction is needed, you operator inputs in the wear offsets. Now, with the help of this station, all those things are eliminated. So you don't need a skilled operator, because this has got an inspection module, a communication module, and analysis module. So it will inspect the job automatically. It will analyze what is the correction that is needed, what quantity, how many microns in length or diameter or bore. And then since it is wired to the machine, it's plugged into the machine. So it will directly send the correction to the CNC. This is how it is able to produce zero defect quality. Now, I want to share something very happy with you, something very, as an Indian, I'm proud of. The world has many technical magazines and journals. One of the most respected in the field of machine shops or manufacturing is called Modern Machine Shop. This is a 95-year-old magazine published in USA, and it is like a Bible for most of the machine shops around the world who want to know what is the latest cutting edge technology in tools, in terms of machines, in terms of other technologies, metrology, all that. Now, last year in June, Modern Machine Shop carried an article about smart correct gauging stations, and they described this technology as the cheapest way to achieve data-driven manufacturing. See, data-driven manufacturing is a very powerful word. It means everything, including Industry 4.0, logistics, other things, ERP, that you are driving your enterprise with the help of data that you are generating from various sources, from the shop floor, from the store, from your, from your customer, etc., from your design office. So they said that this is a beautiful example of a inexpensive digital device which is fixing your quality, which is ensuring that your quality is of acceptable level without need for any human skill. So this was a big feather in our cap that such a prestigious magazine, it honored Marshall and our technology and Indian technology and featured us. So this is how they explained all this in the magazine. So as you can see in this schematic, the basic concept is that job is machined, it is auto measured, auto analyzed, and auto corrected. So this forms a closed loop. I'll just show you a small video about how this works. And you may not hear the sound, it is not important. I don't need to give commentary. Please focus on the visuals. Sorry. Sorry. पीछे कर दे, बहुत पीछे. थोड़ा अंदर. So, I hope you enjoyed the short film. I'll just explain what you just saw in the form of what I call the PDQA cycle. This is a very, very important concept and needs to be understood very well, because this is the magic mantra for zero defect quality. How is it the magic mantra? See, if you want to produce quality without any defects, the first most important thing is to prevent bad parts from getting made. Prevention. This is the first and foremost thing. So the smart correct gauging station helps in prevention. And how it helps in prevention, I will take 30 seconds to explain a technical concept. There is something called the tolerance mean. All the components where some critical parameters are made, each of those parameters or sizes has a certain tolerance, and that tolerance has a mean. Similarly, the size which is being produced, the actual size which is being produced, it also falls within a certain distribution pattern, which is called a bell curve, which is defined by a bell curve. Now, this bell curve also has a mean. Now, what this gauging station does is, by constantly measuring and auto-correcting when required, it makes sure that the tolerance mean and the process mean, they are almost close to each other. Let's say they are almost superimposed or close to each other. The result is that you do not get any part produced which goes out of the upper tolerance limit or the lower tolerance limit. This is how you prevent bad parts or defectives from getting made. So this is the first step. Now what happens? Occasionally you do get a bad part. And how you get a bad part is that, for example, while the finish cut was being taken on a job, the tool got broken or something like that happened. Or it's the first part after a shift change, an operator just presses the cycle start and makes a bad part. Now, when a bad part gets made, the most important thing is that it should not be allowed to get mixed in the good parts or flow down the line and reach the customer. So it's very important it should get detected. So that's the first thing. So our system has this smart detect technology that if a bad part gets made, it is detected instantly by the system and information goes to the concerned people. Now, what is the next step? If a part is detected, it must be quarantined. So we have a technology called Smart Queue, where there is a quarantine bin next to the gauging station. The operator has to put the part in the quarantine bin within a stipulated time. Otherwise, a warning or some alert goes to the senior. So once he puts the part in the quarantine bin, another signal called the queue signal, that the part has been quarantined, goes into the system, which completes the accountability. Now, this is not the end of the story, because if you want to produce zero defect quality, you need to have a system where every time a defective is made, there is an analysis of the root cause, and that root cause is eliminated. So this system sends the information to concerned people, designated people, who have to find out why this bad part was made and write into the system that what action have they taken to ensure it does not get repeated. So once this happens, this is called a virtuous cycle. So once this happens and this keeps repeating itself, gradually you will move from 0.1% defectives to 100 ppm to 10 ppm, eventually approaching zero. This is the methodology, PDQA cycle. Now, we have finished with the I, which was the first component of manufacturing 4.0, IAM. The second, after I, which is improvement in productivity and quality, is automation, and that too affordable automation. See, this PPT was prepared before COVID, and during COVID, all the things that we wrote here are coming true during and after COVID in these circumstances. We were saying in February that affordable automation is a must. It's trouble. It's better to automate. And what we were saying has come true more urgently, because COVID has distorted the whole system in such a manner that either you don't get operators, or you have things like social distancing, so much distance between people and all that. So you are in a mess. So what is the solution? The solution is to have affordable automation. Not only will it solve your problem of Ram Prasad, that's a name, general name I've given to an operator. So Ram Prasad ka problem bhi solve hoga, and also you will be improving your efficiency and reliability. Efficiency means in this case that if your machine is actually running for 20 hours with operators, you will be able to run for 23 hours with automation. And reliability means that the fluctuation in day shift, night shift, day to day, Monday to Friday, because of humans, that fluctuation is not there. So you have a reliable output. You know that, yes, I will be able to produce so much material and deliver on so and so date. So it improves all these things. Now, I will show you an example through a video of some some kinds of affordable automation. Again, audio may not come, it does not matter. Look at the visuals. So friends, this was a short video about affordable automation. And these are some examples of this type of affordable automation without robots for different type of jobs. So some examples are given, typical examples of automotive components. So similarly, you have this affordable automation with robots. And here's a point which I would like to emphasize, that affordable automation is a term which needs to be deeply understood. What do you mean by affordable? I like this term better than another term which is generally used in the industry, which is called low-cost automation. I don't believe in low-cost automation, because if it is something which is low cost in the sense that you have invested lightly, sometimes it can be a jugaad. And we all know jugads, may work at times, but they are generally unreliable. And here, if we want to be world-class manufacturers, we cannot have jugaad. So I prefer the term affordable automation, because affordable here means return on investment. Anything which gives return on investment within 2 years, in my view, is affordable. And what you saw previously, these type of machines without robots, they typically have a return of investment of within 1 year, 12 months. And these types of cells with robots also have ROI within 2 years. Now, how this is possible? This is possible because we have married this automation with generally twin machines. So if you have twin machines, they're close to each other, the spindles. So you can, in this case, on the screen, you can see this machines, if you see my cursor, and this machine, which is 2 spindles each, 4 spindles doing one operation, operation 10, and one robot taking care of 4. And then handing over from an auto gauging station. It's also doing the measurement with the auto gauging. And the other robot picks it up and is taking care of 2 spindles, because the cycle time over there is shorter for operation 20, second operation. So in total, 6 spindles are being controlled by 2 robots. This is what makes the ROI quick, which is why I call it an example of affordable automation. So this was the second part of manufacturing 4.0. The first, I repeat, is improvement in productivity and quality. and quality through auto gauging and the technology, complete technology called IoTQ, Internet of Things for Quality. And then we came to automation. In automation, rather affordable automation, I explained that affordable means ROI within 1 year in many cases, and definitely within 2 years for all cases. So that was the A part. The last part of manufacturing 4.0 is called M. M stands for machine monitoring. See, one of the biggest problems of any kind of I would say initiative taken, any initiative taken for improvement on the shop floor, the biggest problem is that you need to have human intervention to know how well it is working or not working. So you need to have supervisors or inspectors go and ask the operators, अरे भाई ये क्या मिला, efficiency क्या आ रहा है, कितने घंटे चला, piece कितना निकला. All that spoils the whole idea of having improvement system, because you are dependent on humans and you don't get, first of all, you get bad data, you get diluted data, because if things are not good on the shop floor, now people will have an incentive not to reveal that information or to mask that information. Secondly, that data is not available in real time. Third, once that data comes to somebody, he has to fill in all that into spreadsheets, make the graphs, and by the time all that is ready, that thing is over. Then 2 days later, who cares? In the sense that it loses some of its relevance. Now, with the help of machine monitoring, you are getting data in real time, which means every instant you are getting data 24 hours a day, 7 days a week, electronically, digitally, and in most cases through the cloud. That is the approach we prefer, cloud-based, so that there is no IT infrastructure required and there is no way that anybody can sabotage or put down the system. So this is foolproof, tamper-proof, and easy to install and plug and play. So machine monitoring basically picks up, as you saw on the previous screen, from the machine, there is a small black box which will pick up the signals. It will send the information to the cloud where data analytics software is there, which crunches all this data and sends beautiful, highly descriptive, highly useful reports to the consumers. The consumers in this case means the person who's a shop floor supervisor, the production manager, the plant head, even maybe the MD. Once a week he gets a summary of the reports. So reports are in different forms. You can even have live screens on which your data is changing all the time, and you are seeing, as you can see here, that machine to machine, various types of things. What is the present OE utilization? What is going on? All that stuff. You can have on each shop floor, you can put a big screen on each line so that all the people know which machines are performing well. As you can see here, the ones shown in green are exceeding their expected production. The one in orange is on the borderline. The one in red is below, it's performing poorly. So all this live data also motivates the operators or the supervisors to quickly intervene and improve. So you can also have alerts, notifications. You can set limits that if, for example, when the shift ends, if the machine stops producing 15 minutes or earlier than that, before the end of the shift, alert should go to the supervisor. And many other such things. That tool change time, for example, if you have given as 10 minutes, and you can set an alert that if more than 15 minutes tool change time is being used, then alert should go. Or job changeover, if you have given the time of 1 hour for changing from job A to job B, and if that is exceeded, again alert can go. And then also you have Pareto analysis, like the one you see here on the right hand corner on the screen. This is a Pareto analysis. So Pareto analysis basically means that you the system rather generates a report where the order by which each thing is causing that problem, it is listed top down. So the biggest cause of the problem comes first, then second, and so you know where to focus on. So these are some examples of the kind of alerts you get and the kind of reports you get. So now I come to the end of my presentation, and I have taken my time very exactly. So I'll request for at least 2 minutes more, because it's precisely 3:30. So how is IAM unique? How this term IAM is unique? It is unique because whatever solutions you have seen before or heard of before, these are isolated solutions, something to take care of productivity, some kind of device to so-called take care of quality, something else to monitor the improvement in parameters, which is the improvement in the performance. Here what we've done is that we have combined everything into one. Because what is the use if you do partial improvement of something and some other reason is causing you great pain? For example, what is the advantage of having some improvement in the cutting parameters with a better machine, with a high pressure coolant, if your quality is very bad? You're getting, you're producing 2% rejection, and 0.1% of those rejections is not getting caught by the huge number of inspectors that you have put, and it's going to the customer, and you are having those debit notes and unhappy customer. What is the use? So if you really want to have manufacturing 4.0, which will take your company to the global level and help you compete profitably, you need all these things put together. You need improvement in productivity through parameters, through better technology. You need improvement in quality through gauging stations and Internet of Things for quality. And you need automation to drive efficiencies to a level which is much more than humans, and also give you that reliability that, okay, you know that so much output you can get because automation gives you what it promises. And finally, you need a machine monitoring system which is giving you detailed, real, truthful data with analytics 24 hours a day, so that your whole system is being monitored without any supervisor or human intervention. So friends, this is the power of IAM Manufacturing 4.0. Jai Hind.
Thanks a lot, Gaurav sir, for your nice inputs, and I hope participants must have enjoyed all that things, and they will get benefit with all this presentation and all the inputs provided by you. Thank you, sir. So now let me introduce to Mr. Deepak Bal, who is the partner sales manager and working with Dassault Systems India. And he's having more than 20 years of industry experience, and with across various roles in discrete manufacturing and engineering services. And he has extensively worked on software technologies for MCAD, PLM, and digital manufacturing. So let us welcome today's faculty again, Mr. Deepak Bal, and will tell us about the factory of the future. So
thank you, Deepak ji, for the introduction. So I will just share my screen.
The session is handed over to you. So Mr. Deepak Bal, you can keep the session interactive, and even you can ask the questions. And please, in the next 1 hour, you can keep 2 sessions for the Q&A session.
Sure, Deepak ji. So I will share my screen. I think, Gaurav ji, if you can, it's still saying that the screen is being shared.
Gaurav sir, you can share your, please.
Yeah. So, okay. So I hope my voice is clear and my screen is also clear.
Yeah, that's fine.
Okay. I just wanted to check कि सब ठीक ठाक है, and it is okay. So Deepak ji and Dinesh ji, thank you for this opportunity to present Dassault portfolio of Factory of the Future. And
welcome.
Thank you, sir. Thank you so much.
Okay.
So my presentation is for an hour, and I touch upon things which actually constitute the Factory of the Future. So before I get into the details of what the factory of the future is, most of us here on this session are aware about our company, but I thought I'll just take a minute or two just to explain what DESO is all about. So our company, we call it as a company which is working on a lot of scientific tools, a lot of technologies to provide a sustainable world to the manufacturing industry, and we cover a lot of aspect in day-to-day life. As an organization, we are 20,000 strong people across the globe. So we are spread across 995 sites, and to almost most of the countries we cover. We have been very successful. DESO system as an organization is now more than 40 years old, and we have been very successful primarily due to the reason of the product portfolios that we provide to our customers, and that is how they make us successful. We work very extensively with our partners. One of our major partners here in India is EDS Technologies, and globally we have about 12,600 partners spread across the globe. And yes, 270,000 customers all across the world who have been partners to us and who we have been helping all these 40 years. We have three major headquartered locations. For EMEA region, it is basically Paris. For Americas, it is Boston. And for the Asian Oceania region, it is in China, Shanghai. So like I said, we have around 195 offices and 69 R&D labs. We'll be talking in very much detail of this belief system that we have, how the virtual worlds extends and improves the real world. Because the technologies of today, whether we talk about digital technologies or we talk about virtual technologies, are important and how they are affecting our real world. So this session will focus on this aspect as well. So our purpose is to have sustainable innovation. This is very important because as we move ahead in the future, sustainable innovations would be one of the key criteria for any manufacturing industry per se. On this slide, just to quickly, appraise everyone about the history. So we started in 1981 with 3D design. CATIA was one of our earlier products, and we still continue to have that product till date. And then we moved into digital mock-up in 89, and with 3D PLM coming in 99. Then towards the start of this decade, we had the 3D experience platform, and in 2020 we are talking about the virtual twin, but the virtual twin of humans. So we have seen a digital replica of machines or equipment, but now we are talking about a digital replica of humans. So that is how our organization has evolved over the years. So coming to our topic today, and to start off with what I would want to present, most of us would be aware of the portfolio of offerings that we provide. The circle in between that you see is known as the 3D compass. That is our way of presenting the tools and technologies. And the other and all the tools and technologies are sort of provided basis this compass. So whether it's 3D, whether it's virtual plus V plus R, virtual plus reality, intelligence, etc., etc. You might be aware of the more common known tools, and ACMA has a setup which is running most of our tools. So whether it's CATIA, SolidWorks, but today we will be talking about digital manufacturing, which is the Delmia portfolio. With all these brand applications, we are serving almost all of the industries. So all of the 11 industries that we cater to, whether it's auto, whether it's aerospace and defense, whether it's marine, life sciences, industrial equipment, etc., etc. So we cover all the industries, and we have been serving them for the last 40 years. Okay, so now coming to the topic of interest today, I would like to cover this topic with three major points. So I will start off with what are the challenges we face in the manufacturing industry, the three critical elements for success for any manufacturing industry. So when I talk about manufacturing, it could be automotive, could be industrial, it could be high-tech electronics, etc., etc. So manufacturing is common across in anything that is produced, whether it's a laptop, whether it's a mouse, whether it's a car, etc., etc. So I will just take a pause here because I wanted to reflect back to what Gaurav ji was mentioning about, data for quality, digital devices, and a closed loop mechanism, machine monitoring. So these are very critical aspects, and in my presentation, I will be touching on these aspects, how our software technology covers all these aspects. And in case at any point of time, we will have a question and answer session towards the end. But if there is some question that you would want to ask, please feel free. You can maybe, just ask upfront or just maybe drop a message on the chat box and I can take it up. Okay, so let's understand what are the challenges today's manufacturing industries face. Now, this list of challenges that you see on screen is we have identified these critical challenges basis our interaction, our support to our customers over these 40 years. So basis their feedback, we have a very good understanding of what are the common challenges any manufacturing organization faces. So to start off with, the challenge that they face is like digitization of operations, because every day you see new business models coming up, and with new business models there are new demands on manufacturing. So when I say new business models, we are talking about share mobility, or we are talking about electric vehicles. So there are a lot of changes which are happening every day. So a customer or an organization should be able to adapt to these challenges, and that possibility or that agility can only come if you are digital in nature. And earlier it was like you having a product being in the market for years, but now every one year or every 1.5 years you see a new product in the market. So whether it's a new vehicle, whether it's a new equipment, so there are a lot of changes that is happening. So coming to the second point, that is where we understand what we need to do. We need to accelerate innovation, because that is the demand of the consumers today. Consumer wants newer products, better products every next month, or every next 6 months, or every year. So an organization should be agile to provide accelerated innovation. The third is complexity. Yes, as we progress ahead into the future, products are becoming more complex. And I could just take a simple example here, going back to the auto industry. Some years back, or maybe 6-7 years back, the vehicle that you used to drive and the current vehicle that you drive today, there is a lot of difference. There is a lot of telematics, there is a lot of mechatronics in the vehicle. You have vehicles which without you even getting into the vehicle, you can start the vehicle. So there's a lot of complexity which is coming into the equipment itself, the product that you make. And as we progress ahead, you would see though things are becoming more advanced, more complex, but the price parameter, there has not been a phenomenal jump in the price parameter. So for any manufacturing OEM, there is a pressure on margins, etc., etc. And skilled manpower employees are harder to find. So I think this was one of the points which Gaurav ji also highlighted about manpower availability. Organizations are operating globally, serving locally. So this is the fourth challenge that companies face, because even Indian organizations are spreading their wings across the globe, having offices across different countries, but their core DNA remains the same. And that is why we say, even though they are operating globally, but they need to serve the requirements of the local industry. So how can all these things can be done? So this forms a very critical aspect for any organization which is expanding beyond India. The fifth is increase responsiveness. Yes, as I mentioned, because change is inevitable. The rate of change is very fast nowadays, and an organization has to be very agile to respond to the change. This change could be from consumer requirement. It could be from your customer. Change in market scenario, like the current changes we are going through. So most of the auto sector is now focusing on how they can sort of have a digital sales platform. So they need to be, and any organization needs to be very responsive to these changes. Lastly, which is, I think, which goes without saying, drive operational excellence. Every organization wants to drive operational excellence. I recall Mr. Gaurav also mentioning, how can you track the machine efficiency, productivity, etc., etc. So when I say drive operational excellence, it's not only for the machines, but it's for the entire processes that an organization deploys, the manpower that is being used, the advanced tools that are being used. So for any organization, apart from machines, the all the resources that help to manufacture a product, the operational excellence forms a very important aspect. Now, so these are the 6 major challenges that any manufacturing organization faces. And with this, what do we see now? With this, the operational challenges, if I want to sort of break it down, because you have pressure on meeting the quality standards, the regulations with BS6 norms, etc., etc. So there are a lot of government regulations that keep on coming into force, and every organization needs to adapt. So with that, they have to adapt to technology, and technology keeps on changing. So you need to be agile, or you need to invest in that technology, which keeps on upgrading with time. So it's a simple example I could say. So you're using any smartphone, and your Android OS, after a particular time of maybe 4 months, 6 months, there is an update or an upgrade that is provided. So is the technology that you're using, keeping itself updated to the latest trends and the future trends? So that is important. And with, increase in usage of technologies, with new types of raw materials, with inflation, how do you maintain your costs? Customers today are moving towards mass customization. It is not mass production. So every customer has a unique requirement. So this is another challenge. So you find that in a lot of automotive products, there are a lot of variants that customers are being provided with because for their liking of mass customization. Sustainable operations, yes, very important, because we owe this to our earth, that whatever we do are sustainable and does not harm the environment. That is why you see all these norms of BS6 and all coming up. And lastly, workforce of the future. So this is one critical aspect, because with all these new technologies coming in, we need to ensure that our workforce, how well they are trained, how they can be trained, and keep themselves updated with the latest technologies. Because any product that is made, it has 3 critical factors: raw material, machines, and manpower. So, the raw material and machines, to a certain extent, maybe we can control. And workforce of the future, there's a lot of training and hand-holding that is required. So these are some of the challenges, operational challenges, that any organization faces. So how do we address these 6 major challenges, these operational challenges, to ensure that any manufacturing organization is successful? So there are 3 main critical aspects which has been listed here, which are important for any manufacturing industry today to achieve success. When we talk about value networks, it is basically how you are, collaborating with your suppliers, how you're ensuring that your suppliers or maybe your customers work in a very, connected environment to enable new business models and sustainable innovation. So that is what we mean by value networks. Sustainable innovation and excellence. is one of the critical elements because it drives your operational performance, efficiency of your operations, and it is where the three aspects which I was just speaking about, two of the main contents of those aspects, the people and machines, come together to produce or to provide or to enable operational performance. Lastly, workforce of the future. Yes, because any machine, any technology, any process, any innovation is driven by manpower, uh, by by people who are driving those tools or technologies. So they should be in a position to capture what is happening in the real world, model it, reuse it, and store that knowledge so that future generations or people coming in later can reuse those knowledge and improve on those knowledge for common benefits. So how do we now achieve these elements of success? So what Dassault system has sort of the concept what we have come up with is known as the factory of the future. Now, why we call it factory of the future? Because the factory of the future is not only solving your current issues, but it is a concept which will look into the future aspects of how the industry is moving, and it is enabled, scalable enough to meet all those challenges. So the future of manufacturing will be basically, which interconnects machinery, systems, but in on the production side, and also, your clients, your partners, and sites across the country or across the globe. So it enables new ways of inventing, learning, producing, and trading. So this is what a factory of the future definition is all about. And the word, two, three important words that I just want to highlight again is, interconnected machinery, systems, partners, production sites, and clients. So you see, not only the systems, the sites, but manpower is getting connected to enable innovation for the future. Now, with the next slides, I will get into details of the technology that we have. So our technology is based on our compass. So the circle that you see on screen is known as the Dassault Systems compass, and most our technologies are based on this philosophy. So the 3D experience platform is basically the virtual experience platform approach to manufacturing excellence. And the 3D experience platform provides a global operation management cockpit that uh, captures knowledge, decision making support for operational excellence. So I will give you a glimpse of what I mean by this 3D experience platform and how it connects together. And when I say a cockpit, it is basically a dashboard, you know, uh, which sort of monitors the entire processes which is happening on a factory, gives you a real-time feedback, and connects the virtual and the real world. So I'll explain those in my next slides. So just to take this explanation further,
Hello.
Hello.
Hello, Deepak ji. I think he lost the connection, so just wait for a minute so that let him rejoin.
Deepak, have you spoken to the faculty?
Yes, yeah, just now I spoken with him, so he's going to connect again.
Okay, okay, no problem.
Hello, I hope you can hear me. Deepak ji, can you make me the, can I share my screen now?
Yeah, Deepak, you can please.
Okay, I'm sorry, मेरा network थोड़ा सा disturb हो गया था, so I will just, I hope.
It is technical issue, so everyone faces.
Okay, I hope आप, yeah, मेरी screen देख पा रहे हैं? आप मेरी screen देख पा रहे हैं?
Yeah, Deepak.
Okay. I'm sorry for this. So I think I was on this, the virtual experience platform approach. So I was talking about how Industry 4.0 is a concept which is now a thing of the past, because things have dramatically changed in the last 1 year or so. So when we were talking about Industry 4.0, it was basically the seeking data from the physical resources. That is when we said the seeking information from the real world. As we move ahead today, it is basically modeling the physical resources. So when we say we model the physical resources, we are creating a virtual twin. So it's the replication of a physical resource in a digital environment. And that is where your value chain, whether we talk about the processes, your suppliers, your customers, how they can collaborate in a digital environment. The future talks about integration of both these aspects, which is V plus R, and this is basically the 3D experience twin we will be talking about today. And what this does is this basically is marrying both the virtual and the physical world, and there is a continuous feedback which happens in this scenario. When I say a continuous feedback in this scenario, it is basically ensuring that once a process is defined in a virtual world and it is executed in the real world, the feedback goes back to the virtual world for a continuous improvement. So this is an important concept of the 3D experience twin that I would be presenting here today. So I'm on my next screen. So now let's understand what a virtual experience platform for Factory of the Future is. So if there are any questions, I'm open. Maybe I can take a minute or two to know if there are any questions, or I will just sort of move ahead and present to you the Factory of the Future concept.
So there is one hand raised from Mr. Anil Misra.
Okay.
Mr. Anil Misra, you can unmute yourself and ask your question, please. I think there is no response from their side. So
okay.
Anyone having any question, so you can raise your hand, or else you can put your question in your chat window.
Maybe you can just unmute yourself and ask the question.
Yes. So I think you can continue.
Okay.
No, sir, clear mic. No issue.
Okay. Okay, Anilji, so we will move ahead. Okay. So now let's understand what the Factory of the Future, how it works, how it comes into picture. So we have categorized the Factory of the Future into 4 major layers or buckets. So those 4 layers are process engineering, manufacturing engineering, value network engineering, and operations. Now, all these are in a digital environment, and they constitute the entire operations of any manufacturing organization. So let me start with one by one on them. So let's talk about process engineering. So process engineering is basically defining your plant layout, because obviously if you want to set up a factory, or even if you want to change the existing layout of your plant, you need to define the plant layout, simulate in a virtual environment how the factory flow happens, simulate the machines, simulate the manpower who's going to work on those machines, and train your people so that they can adapt to the new layout. So I have few videos here which will explain this concept. I hope the videos are clear. Maybe due to the network, the videos might be a bit slow, but I will still try to explain this concept. Now, what we saw on screen was a digital representation of a factory, of an existing factory. Now, like I was discussing earlier, that every 1 year or 1.5 year, or maybe earlier, there is a change in product, and your customer could be asking for a new product or a new production line because of the new product that is going to be released in the market. So how do you sort of ensure a quick response, or bring those changes into your factory? So what you see on screen is an actual video of our software running, and where the entire factory has been modeled, and the changes can be done in a digital world. So even before you incorporate those changes in the real life, you can digitally analyze those changes, see whether they fit into your existing factory. Are there anything else, or any further equipment, tools, accessories that you may need to provide to ensure that the new production line is set up. So all that you can do in a digital environment or in a virtual environment. So once that is done, on my next screen, you can see we are simulating the entire factory in a virtual world. So you can see people moving, you can see AGVs, which is automated guided vehicles, moving around the factory premises. And what you also see is some information being tabled up. So information is nothing but data. So whenever operation is happening in a factory, the system analyzes the the efficiency of the manpower or the equipment, and on real-time basis, it is going to provide this information to you, so that you as a organization, you are aware, is this the right factory layout? Are there other things that I need to change so that my efficiency of my manpower increases? In this example, you see that people moving around, picking things from a conveyor system, placing it to another station, etc., etc. You also see machines, guided vehicles moving around. So depending upon whatever is the requirement, this simulation can be done in a virtual world, and you can analyze whether this is the right layout for the new production line. So I move. We were talking about ergonomics. Now, this is a very important aspect, because many times, if I have designed my workstation in such a way that the worker working on that workstation fatigues earlier, so his productivity will decrease. So the system is smart enough to analyze whether the ergonomics of the workstation are right, whether this is the right height of the workstation. And if it is not, it will give you those information that this is not the right height of the workstation. Maybe you need to reduce the height so that the worker can work efficiently with lesser or no fatigue, and obviously his productivity increases. So in the virtual world, it is not only the machines or the equipments that you're simulating, even the human man can be simulated to see the overall efficiency of them. When you have a new production line, you need to train your people. So training could be for two aspects, because there is a change in the production line. There is a change in the setup of the workstation, so you need to train people. What you see on your screen is a virtual training environment where the entire process of assembly is being created in a virtual scenario, and the manpower or the operator can easily sort of practice, learn, and start his operations. This is also important because nowadays we see a lot of temporary manpower or contractual manpower being used in an organization. So it is important to quickly train them on the new product. Or if you have manpower, there is a turnover of manpower. You have new people coming in month on month. So instead of having a supervisor spend his time training these people, you can have a virtual environment which will train the manpower, and they can quickly get onto the production line or the assembly line to start their work. So process engineering, I will just quickly summarize, covers the virtual environment, whether it's a production line, a plant layout, whether it's a human person that we want to simulate, whether it's the machines, etc., etc. Now coming to manufacturing engineering. Manufacturing engineering basically covers three main aspects. That is your product definition, how the product is going to be manufactured, that is your process plan, and the work instructions for that, how that assembly is actually going to happen. So let me just quickly show you this. I hope the videos are clear and आप देख पा रहे हैं और कोई blurness नहीं है, और अगर कुछ ऐसा है please let me know. So maybe I'll go a bit slow. इस एग्जांपल में जो आप देख पा रहे हैं बेसिकली द सॉफ्टवेयर सिस्टम विच इज हेल्पिंग यू टू डिफाइन द प्रोडक्ट डेफिनेशन कि ये प्रोडक्ट कैसे बना है, इसके अंदर क्या क्या पार्ट्स हैं, सब असेंबलीज हैं, एंड हाउ दे आर फिटिंग इन टुगेदर. क्या ऐसे कुछ पार्ट्स हैं जो आप कॉमनाइज कर सकते हो, जो आपके एग्जिस्टिंग पोर्टफोलियो में अवेलेबल हैं, so that you save time and money and you don't have to recreate from scratch. So all that is possible in a virtual environment, and ये जो आप स्क्रीन पर देख रहे हैं, it is showing the product definition for a given particular product. अब इसको प्रोडक्ट को बनाने के लिए हमें एक प्रोसेस प्लान डिफाइन करना है कि असेंबली लाइन पर क्या क्या एक्टिविटीज होंगी, फर्स्ट, सेकंड, थर्ड, व्हाट आर द सीक्वेंस ऑफ एक्टिविटीज, कितनी सब असेंबलीज लगेंगी, कितने बॉट आउट आइटम्स इसमें आएंगे, एक्सेट्रा एक्सेट्रा. सो बेसिस द प्लांट सेटअप दैट वी हैव, हमें ये डिसाइड करना पड़ता है कि ये इस प्रोडक्ट को बनाने के लिए क्या हमारा प्रोसेस प्लान होना चाहिए. तो सिस्टम ये सारी चीजें सॉर्ट ऑफ मैप करता है, इंश्योर करता है दैट वी हैव डिफाइंड द राइट प्रोसेस प्लान टू मैन्युफैक्चर दैट प्रोडक्ट. जो अब आप स्क्रीन पर देख रहे हैं, दिस इज द इंफॉर्मेशन पर असेंबली स्टेशन. कि एक असेंबली स्टेशन कुड बी केटरिंग टू डिफरेंट प्रोडक्ट्स. तो हाउ इट इज लोडेड, क्या हम प्रोडक्ट टाइम पर बना सकते हैं, हमारी शिफ्ट 24/7 रन हो रही है या 2 शिफ्ट्स इन अ डे रन हो रही है. सो इसके बेसिस पर क्या ये प्रोडक्ट की क्वांटिटी विच नीड्स टू बी डिलीवर्ड टू द कस्टमर, कैन वी मेक इट. इफ देयर इज एनी डिले, the system captures all that information. So the system is actually capturing data, and this data is not only from the machines, it is from the equipments that is being used. So equipments could be equipments such like conveyor systems, for example, could be an equipment. So machines जो आपकी manufacturing machines है, maybe a CNC machine, VMC machine, etc. All those information are getting captured. Equipments same information capture हो रही है, ह्यूमन वर्कर से भी इंफॉर्मेशन कैप्चर हो रही है, बेसिस विच द सिस्टम इज गिविंग यू फीडबैक कि क्या ये प्रोडक्ट उस डिफाइंड पीरियड में, उस टाइमलाइन में बन सकता है कि नहीं बन सकता. लास्टली, एज पार्ट ऑफ द मैन्युफैक्चरिंग इंजीनियरिंग इज द वर्क इंस्ट्रक्शन. सो वर्क इंस्ट्रक्शंस में क्या है, बेसिकली हम एक्सप्लेन करते हैं कि ये प्रोडक्ट किस तरह से बन रहा है, व्हाट इज द असेंबली सीक्वेंस, किस मशीन पर जाकर इसको रखना है, कैसे रखना है और कैसे बनना है. This is critical again for new manpower that is coming in. अगर आपको कुछ full proofing करनी है तो आप digitally इसको simulate कर रहे हैं, and then accordingly आप full proof कर पा रहे हैं. So all these things become a part of your work instruction. This work instructions आप एक video file बनाकर और एक PDF file बनाकर you can circulate across teams. So even before they actually get into the production shop, ये information उनके पास है and they can start to do their work accordingly. Now moving to the third layer, which is value network engineering. So when we talk about value network, it is basically आप अपने sales operation plan कर रहे हैं, logistics plan कर रहे हैं, plant traffic plan कर रहे हैं. Now from a manufacturing organization, operation plan करना is very important because रॉ मटेरियल कब ऑर्डर करना है, या अगर कोई न्यू इक्विपमेंट चाहिए वो कब तक आनी चाहिए, मैन पावर अगर एडिशनल चाहिए तो वो कैसे ऑर्गेनाइज करना है. सो ऑल दिस फॉर्म्स अ पार्ट ऑफ योर सेल्स प्लान्स एंड ऑपरेशन. सो व्हाट यू सी ऑन स्क्रीन इज बेसिकली analysis or intelligent analysis, I would say. आजकल हम ये टर्मिनोलॉजी काफी सुनते हैं, आर्टिफिशियल इंटेलिजेंस एक्सेट्रा एक्सेट्रा. सो दिस इज वन ऑफ द एस्पेक्ट्स ऑफ दैट. सो व्हाट यू सी ऑन स्क्रीन, अगर आप राइट साइड की स्क्रीन देखेंगे, इसमें कुछ नंबर्स हैं. सो बेसिस कि आप क्या बनाना चाहते हैं, कब बनाना चाहते हैं, किस प्लांट पर बनाना चाहते हैं, द सिस्टम विल टेल यू कि अगर आपने ये प्रोडक्ट इतनी क्वांटिटी में इस प्लांट में बनाया तो प्रोबेबल आपका मार्जिन इतना होएगा, प्रॉफिटेबिलिटी इतना होएगा, क्योंकि यहाँ फिक्स्ड कॉस्ट ये है, इन्वेंट्री कॉस्ट ये है, ट्रांसपोर्टेशन कॉस्ट ये है, एक्सेट्रा एक्सेट्रा. सो ऑर्गेनाइजेशंस एज वी नो हैव मल्टीपल प्रोडक्शन साइट. आप मानेसर में बना सकते हैं, आप गुजरात में बना सकते हैं, आप चेन्नई में बना सकते हैं, डिपेंडिंग अपॉन आपका कस्टमर कहाँ है. बट ड्यू टू सर्टेन फैक्टर्स हो सकता है गुजरात में कंपनी को एक टैक्स बेनिफिट मिला हुआ है जो मे बी मानेसर में नहीं है, हो सकता है चेन्नई में ना हो. सो अ कंपनी कैन टेक अ डिसीजन दैट ड्यू टू दिस टैक्स बेनिफिट, इफ आई प्रोड्यूस दिस क्वांटिटी इन गुजरात and ship it to Pune or maybe to Gurgaon, I will maybe be making more money. I will be making more profit. I will be making more margin. So the system captures all that data and provides the information in real time. This is one aspect of planning, sales planning and operation. Then we come to the second aspect is logistics. Now, जब भी आप कुछ product बनाते हैं, you need to transport it to the customer. Now, depending upon, you may have a rate contract with the transportator कि अगर हम इतना quantity इस transportator से भेजेंगे तो इतना वो चार्ज करेगा, किसी और से भेजेंगे इतना चार्ज करेगा, अगर बाय एयर भेजेंगे तो इतना चार्जेस होएगा. So you can simulate all that because all this information आपको rate contracts पता है, freight cost पता है, air fares पता है, etc etc. You can put it in the system, simulate that to transport this in the given time, what is the best available option. So जो आप top पर ये जो figures देख रहे हैं which are changing dynamically in real time depending upon आपने क्या location for a particular product आपने select किया है for transportation, it will give you those values. So this is all again data that is being used in a very intelligent way to give you information. The last is organizing your traffic inside your plant. So plant के अंदर lot of equipments are moving. So they could be automated guided vehicles. They could be conveyor systems. There could be forklifts, etc., etc. And you want to optimize कि I'm using my plant in a most efficient way. So that is a way of increasing the plant efficiency and productivity. Lastly is the operations management part, which covers your daily scheduling, day-to-day scheduling, manufacturing operations, IIoT, Industry 4.0, you can give it different names, manufacturing analytics and lean management. So let me just take a minute to explain what we have on screen here. If we recall, Gaurav ji was talking about machine monitoring. So we will come to that aspect, that how machines can be monitored. On this slide or on this video, that what you see is monitoring the production efficiency of machines, the scheduling of machines, which machines are running as per 100% capacity. Those are all in green. जो थोड़ा सा कम कैपेसिटी में रन कर रहे हैं वो ऑरेंज में होएगा, और जो बिल्कुल बिलो कैपेसिटी में भी इन रेड और समथिंग लाइक दैट. So you can have a real-time update of all the machines on the shop floor, whether it's a CNC machine, whether it's a robotic machine, whether it's a grinding machine, etc., etc. So जो आप screen पर देख रहे हैं, color codes define, इस machine पर at a given time कौन सा product बन रहा है, कितने quantities बन रहे हैं, और whether there is any delay or downtime for those machines. So एक single dashboard.
I want to interrupt for a minute, please. So actually, some are from south part of India also, so they are preferring English language only, please.
Okay. I'm sorry for that. I thought okay, I'll do it. So I will continue in English only. Okay, so what like I was saying, what you're seeing on screen is the the analysis of all the machines which are on the shop floor, how they are working, what is the efficiency, what are the parts they are producing, etc., etc. So when we go to manufacturing operations, so this is a dashboard which is typically available on any modern shop floor. So what is dashboard is showing, at the assembly line, what are the operations being conducted. So assembly station 1, what are the operations? Are there sufficient raw material to carry out those operations? Is there any delay in operation? So what you see on the left is the various assembly stations. So we are capturing all that information and providing it in form of a dashboard. Now this dashboard, since the system is digital in nature, this dashboard can be made available on a desktop system. It could be made available on a tablet, and a person maybe sitting hundreds of kilometers away across the internet can have a look at what is the efficiency, or what is the production process happening at the plant level. So what you see on screen are the dashboards that come with the software, with the technology, and you can map the entire production process to the operator. So what you see on screen are faces. So you can identify that for this particular operation or assembly line, who are the operators that are working. Now what you see on screen is a virtual representation of the assembly line. So green indicates that everything is fine. Orange, maybe there is some delay because of maybe raw material not present, or there is a stoppage because of some equipment not working, etc., etc. So all that information is captured in real time. So it could be, when I say information, it could be information from a handheld scanner. It could be from any machines which is connected through a PLC system. So all any information can be easily captured from the assembly line. This screen basically shows the performance of the assembly line. Has there been any delay? What is the takt time? Are we achieving the takt time, or there are any issues, etc., etc., so that you can do a root cause analysis and see what were the reasons for that. Now, coming to the next aspect, it is basically talks about manufacturing analytics. So this is capturing the performance of the machines. So we heard about OEE. So this is basically capturing the overall equipment efficiency. What is the time the machine was available? Was there any downtime? What could be the reason for the downtime? Due to the downtime, how much productivity was lost, etc., etc. So this is all real-time information. It is not that someone is going and inputting this information. This information is being captured as the machine works. So as the machine continues to work, there are sensors on the machines which can be used to capture real-time information. So sensors can, you have a whole portfolio of sensors. There could be energy sensors, there could be motion sensors, there could be etc., etc. So to capture whatever information, because efficiency of equipment also depends upon many other parameters. So that can be easily captured through these sensors. Lastly, when we talk about lean management, now this is something which is very important for organizations, because they need to ensure that all the operations which they are taking care of should be planned in a very efficient way, or in a very lean way, so that there is no sort of duplicacy of work, or there is no productivity loss. So when we talk about lean management, what you can also do is for digital collaboration. So what you see on screen is, assigning tasks to supervisor, having a quick meeting. So this quick meeting could be on form of a whiteboard, where you can just, sort of write a note, send it out to the supervisor, and that information is available to the supervisor on his tablet, and he can take decision accordingly. Vice versa, if there is an issue at the shop floor and the supervisor wants to report to his management, especially in the current scenario where you have social distancing, so he can just quickly pull out his tab, write that message on this tab, and that information gets captured not only into the system, but to his senior management, and the decision can be taken effectively. Now, it could so happen that his supervisor or the senior management is not present in office. He could be in another plant location, but that information comes to him, on a click of a button, and then he can send his message or instructions back to the production line operator, etc., etc. So this basically showing how the system actually works, how you can assign your work order to different people in your team. So with this, I've sort of captured or tried to present what are the four main key pillars of a truly, digital manufacturing entity, and we call it the factory of the future. So these are the four main pillars, and I hope I was able to provide a good explanation of all these four pillars. So to summarize, the factory of the future is basically virtual world extending and improving the real world. So like you saw, we model whatever needs to be done in a virtual world, and that information is then sort of carried or provided to the real world environment. Now the real world environment performs those operations, and the feedback from the real world is then again brought into the virtual environment to improve it further. So what does it mean? That suppose today I'm doing an operation, and when I do it in the real world, there is some feedback. How am I, or how can I improve the operations, week on week, month on week, month? So it is like telling me, how do I do a continuous improvement in my processes? So there has to be a continuous feedback between the virtual and the real world. Capturing knowledge and know-how, very important, because without having such a system, the knowledge or know-how is left with the operator or this line supervisor or the managers who are managing the shop floor. And as they move from one role to another, or they leave the organization, all these information knowledge is sort of gone away with them. So it is important the best practices being captured and being reused every day on. Empowering collaboration and decision support, obviously, because you have all the data available with you, real-time data, so it is very easy for you to take quick decisions. And since the data is available from from all the operations in the factory, so you can collaborate and take decisions accordingly. So with this, what we have seen as of now is the virtual experience platform or factory of the future, which is actually helping us to address the three key elements of success to achieve a digital experience that not only improves your productivity and competitiveness, but it also enables the merger of both the virtual and the real worlds to provide continuous improvements and experiences to the users. So with this, I have concluded my presentation, and I would also encourage all the audience today to please visit our website, which is dedicated for this concept. So it is www.3ds.com/factory of the future. I've just mentioned it on my slide, and whatever I've tried to explain in this 1 hour, it captures the entire concept. It has a lot many videos which are very informative and gives you an idea of how the factory of the future would look like. So with this, Deepak ji, I have concluded my presentation. So if there are any questions which which the audience may want to ask, please feel free to ask me. I guess I'm almost right on time with 5 minutes more to go for the Q&A. So please, take this time to let me know if you have any questions that I can answer right now.
Yeah, thank you, Deepak ji. So if participants do have any questions, please, you can unmute yourself, you can ask, you can put in chat box also.
Hello.
Yeah, Mr. Anil Trivedi, right?
Yeah.
Yeah, Anil, please go ahead.
How does this virtual twin means that in the real world, whatever feedback is coming, that is created here virtually, and the solution is found out and then communicated back there? Is it something like that?
Yes. Could you just repeat your question? I missed. I'm sorry.
This virtual twin
Yes.
that you have used. So does it mean that whatever feedback is coming from the real world application, that will be regenerated here virtually, and the solution may be found here or and that can be communicated back there to real world.
Yes. Okay. So what happens is when we start a new operation, what we do first is model that operation or the process in a virtual environment. So once we are sure that this is going to work in the real scenario, we provide the information or transfer that information to the real world environment, and that process gets executed. So once the process gets executed and we find that there could be some gap between what we simulated in the virtual world and the real world, so that feedback from the real world is again put back into the virtual environment to further improve on the processes, and then again that output goes to the real world. So it's a continuous loop that happens, and that there is definitely an exchange of information from virtual to real, real to virtual, to keep on to have this continuous improvement happening.
Okay, thank you.
Yeah.
Deepaki, there are some comments in chat box also. Please explain about 3D twin again, 3D twin experience.
Okay.
And you can open the chat box and please have a look.
Yes, I will just do that. I think I need to. Yes.
Should I read for you?
No. I can. I see the chat box. Okay, so I see one question which says, please explain about 3D twin or 3D twin experience. Okay, when we say 3D twin, it's basically like the word says twin. It is like creating a replica of the real world. So a simple definition, if I have to give, is creating a replica of the real world. So real world, you have 2-3 main components: your machines, your manpower, and your equipments. So I'm creating a virtual environment which will capture the manpower. You would have seen in the videos that I played that there was a virtual human being moving across the plant layout, and then you capture the machines or the equipment. So I'm creating a virtual twin of the real world. So that is what it is meant. I hope I have answered your question. Okay, then I see one question from Sanjay which says, this system can be implemented in any factory? Yes, this system can be implemented in any factory, whether it's a modern factory or an old factory, because there are ways to seek information from the equipments. So there are now, you have a lot of sensors which are easily available. So it's basically capturing information from those equipments, putting it into the system, and creating a virtual environment and sending the feedback to the real world. Yes,
I think Deepak, I think question is like that the system has been implemented in any factory. I think they want to know if it is already implemented in anywhere.
Okay. So if I need to talk about India specific, yes, there are organizations which have already implemented this system. So maybe if I get into a one-to-one discussion, I can share those names also. But we have companies. If I could just quickly take names like Havels, like Hero Motor Corp. Those are the larger organizations which has implemented. But we have companies from tier 1 organizations also who are in the process or who have already implemented such a system. The criteria here is that you don't have to go and deploy the whole system in one go. So you remember the 4 layers that I was talking about of factory of the future. So you can select which is the layer which is more critical, and you can start with that layer and pick on critical modules. I would say this is a modular in nature system, so you don't have to do everything in one go. So I hope Sanjay, I was able to answer your question.
Yeah, thank you, Deepak. Thanks a lot. I think there is no more question seems there. So I would request to Dinesh Pathak sir to come on screen now, please.
Just give me 1 minute.
Okay, sir.
Yeah, good evening, both the faculties, and I hope participants have enjoyed the session. Can I have one person's feedback? Anyone? How was the session?
Sir, the feedbacks are given in chat box also. So Mr. Chinna Matru is saying good insights, thanks. And some more already has written.
Okay.
So they enjoyed, yes.
Okay, somebody is writing, Mr. Chirag, that yes, it was good.
Yeah, thank you
Okay,
both.
anyhow, so I think we'll be closing this in another 30 seconds or 1 minute. So we appeal that, some Archana is saying that it is very good. So thank you very much. And I just want to inform that we have other programs also. Deepak, can you share my PPT?
Yes, sir.
I will take another 1 or 1.5 minutes for my upcoming program. And if you are interested, you can contact our team. So now a lot of discussion is going on about what is the new normals for the future manufacturing. Can you put the slideshow?
Yeah.
Yeah. So this first session starts on 17th, that is day after tomorrow. And I'll be covering, next slide, please. So I'll be covering what is the current situation and what should be our response. And these are the topics like cash flow, manpower management, cost management, speed to market, safety, new business. So these are the major topics I'll be speaking on the day one. And what you can get is that how to bounce back and opportunities for digitization. I think today's presenter Gauravji was there. And very important is that we need a different skill now. Because current skills is not going to work, and what are the areas where we can develop the skills and what are the gaps and how to manage the cash flow. That was this is regarding the day one. Can we have the next slide, please? Day two, I'll be covering the most important topic called changing the mindset, and I drive the zero defect cluster programs, and I'll be teaching you the basic difference between problem solving and problem killing, and how to develop that skill, what is the silent brainstorming session, and what are the breakthrough projects in quality, breakdown, inventory, and customer satisfaction. And finally, important is that how to build the zero defect culture. And I drive another topic called inventory-less production, or you can say air-to-air manufacturing. And the last session will be, next slide, please. Yeah. So this will be the last session, that how to make the decision making skills to the bottom line, starting with leadership, associates, and support functions. And most important is that unless we empower the people, so what is the process of empowerment? And you have heard the Japanese 7 type of wastes. These are very well defined, but I have my personal DVPs 25 wastes. And if you somebody is saying please share this training are free. This is a paid program. The fees is for 3 sessions, it is 4,000 for members, and there is a discount also. I think that is available on the last slide. And if you are interested to understand what are the 25 types of the waste, and if you understand that each waste will have one opportunity in each machine. So just imagine on each machine you get 25 opportunities. Like that, whatever the number of machines are there. And finally, I will make you little jealous by telling the benchmarks like inventory, which are the companies and what is the inventory level, or quality, which are the companies, or customer satisfaction, or in it financial per value addition per employee. And I will also provide the soft copy along with my 25 wastes Excel sheet, where you can put your data and do scoring for your companies also. Next slide. Yeah. This is my profile. You can see anywhere. Next slide. Yeah. So somebody is asking what is the piece. So this is this PDF PPT file my colleague will share you to all. And there is a discount policy also. I think for 2 or more some discount, and 4 or more some discount. So if you are looking forward, can you stop the sharing the slide? Deepak? Yeah. So if you are looking
Sir, your voice is breaking.
Your teams, you can approach my team. Otherwise, more also. So my colleague will do register as per your choice. So finally, from ACMA Center of Excellence, I would like to thank all the participants and our 2 faculties. And we know that there are a lot of problems in the internet. And today, Mr. Mukesh Ambani announced that the Jio Meet, they conducted their annual general meeting also today. And I think they have also announced that 5G they are going to bring in the market in another 2-3 months time. So I think with these problems also we are able to do programs. I will not say 100% right in the telecommunication, but I think 95 to 96% we are able to hear properly and see. So thank you once again, and I say that take care, be safe, and we'll bounce back. Thank you very much.
Thank you, sir. Thanks everyone.
Bye.
Bye.
Thank you everyone. Thank you so much for your great support.